Hello everyone, welcome again to the YouTube channel of Mathematics Experts. Today we'll be solving this limit problem. If you are new to this channel, kindly hit the subscribe button and like this video, and do not forget to share this video to your learning colleagues. So we have the limit as x tends to 0 of x squared sine squared x divided by x squared minus sine squared x. The first thing to do here now is to test it, put x equals to 0 into it. So what do we have? We have 0 here, that will be 0 there, and we have 0 here. Sine square 0 is still 0, so that will be 0 over 0. So because we are getting indeterminate, what do? We are going to use either L'Hopital's rule or the series expansion, but I do not want to use the series expansion to solve this problem. So I will simply use, I do not want to use the L'Hopital's rule to solve this problem. I want to use the series expansion to solve this problem. Now, what is the series of sine x? Sine x is x minus x cubed over 3 factorial plus x to the 5th power over 5 factorial. Then it keeps on going to infinity. Now, x is approaching to 0. For x to be going to 0, it means that it is not getting to 0. It is either more than 0 or it is less than 0. Are you getting it now? So for the approximation for sine x, we usually use the first two terms of the series expansion of sine x, because all other power, as the power keeps on increasing, their values as x approaching 0 will keep on getting smaller and smaller, and a number that is very infinitesimal cannot contribute more to the whole result, so it contributes less. So what do? Whenever we see sine x, we put this series. So we have the limit as x approaches 0, then I put my x squared, then my sine squared x, I have x minus x cubed over 3 factorial is 6, right? Then divide by x squared minus this one also, I'll put sine squared x, x minus x cubed, so this is squared, all over 6 all squared. So what are we going to do here now? We are going to open the bracket. Now notice that the highest degree in the denominator is, before it was this x squared, the highest degree of x is to the power of 2. So let's open the bracket. So we have the limit as x approaches 0 of x squared. Now I'm opening the bracket of this is x squared minus this times this, that is x to the power of 4 divided by 6, then times 2, that's x to the power of 4 divided by 3, then raise this to the power of 2, that should be plus x to the power of 3 times 2 divide by 6 squared, that's 36. Then all divide by the same thing here also. I'm also going to be expanding this. That will be what? That will be x squared minus this times this. So let's put parentheses here. So this times this is x to the power of 4. So I'm multiplying it by 2. That will be x to the power of 4 over 3. Then this also is plus x to the power of 6 over 36. So now, if we continue to do this now, I'm going to rub off this place. I'm going to rub off that place. So now look at it now. You find out that we have this here. So we can open the bracket. So limit as x approaches 0. Opening the bracket, we have x to the power of 4 minus x to the power, this times this, that's 6, divide by 3, then plus this one is to the power of 6, so x squared times this is x to the power of 8 all over 36, then divide by, I open the bracket here also, x squared minus x squared plus x to the power of 4 over 3 minus times plus, that's minus x to the power of 6 over 36. Now notice that this cancels this out. Are you with me? and at this place we have x to the power of 4, x to the power of 6, x to the power of 8. So what are we going to do here now? We can't just plug in 0. So let us factor out the x to the power of 4 that is common here. So factoring that which is common there, what do we have? We have the limit as x approaches 0 of x to the power of 4 bracket 1 minus x squared over 3, then plus x to the power of 4 over 36. Then all divide by x to the power of 4 is here. We have 1 over 3 minus, if we remove it here, we have x squared over 36. So this can cancel this. Now note that if we plug in 0 directly, what are we going to have? We are going to have 0 here. This is 0 over 3, 0 over 36, 0 squared over 36. So all those things are 0. So at the end of the day, we have 1 over 1 over 3. And the answer here is 1 over 1 over 3 is simply 3. Therefore, the limit as x approaches 0 of x squared sine squared x divided by x squared minus sine squared x is equals to 3. If you find this video interesting, kindly hit the subscribe button. Do not forget to like this video and share to your learning colleagues. Bye bye.